Assalamu alaikum warahmatullah. Welcome everybody to Practical Numerical Methods for Scientists and Engineers. Here we have our Module 5, Descriptive Statistics, second part. In the first part, we already know how to calculate the numerical regression for the linear polynomial first order, second order, and using Excel as well. So now we want to create a function to find the coefficient of linear regression using this matrix. So first we have put our assumption. We have inputs, so we have x as independent variable and we have y as dependent variable. Also we need output, trend line, equation, and we need to find the correlation coefficient. So this is our requirement. The first important step is to check if x and y are equal. So if they are not equal, then I can't find anything and I should get an error message. Okay, so this is my script. So just I want to explain the script. Now this script to create a function, so this is called function. I named the function trend line, okay, xy. So here I have two inputs, x and y. When you start a function, you have to end it by end. Okay, this is to end the function. So now if you want to put comments to identify the function, then you can start with percent. So when you start with percent, so any comments you put after the percent will be just comment, it's not quotes. So I put this function is to create a trend line equation and calculate its r and r square, and it's written by Ahmed al-Khattat. So now let's start. Now first step we want to do is to check the length of the two vectors. So I put this condition: if lengths of x are not equal lengths of y, then error x and y. This will be shown, x and y must have the same length end. Okay, so this sign doesn't equal, doesn't, not. Okay, this mean okay, no. Okay, so now now we want to do one thing. We want to do to calculate the summation. Okay, summation. So in order to calculate summation, as you know, in MATLAB it calculate only based on the vectors, only vertical vectors. Okay, it can be calculated based on horizontal. Okay, so now I want to put one step. If the data is given by the user as vertical, it will keep as vertical. If the vector is given by the user as horizontal, then it will be converted to vertical. To do this one, so I will let the MATLAB know. I will tell the MATLAB x equal x column between parentheses and y equal y column between parentheses. This one convert all horizontal to vertical, and if it horizontal, vertical, it keep it as vertical. Okay, now we finish this step. Now we want to create the summation. Okay, so let's start. I will call this one sx, this one sx, this one I will call it sx2, this one I will call it s summation y, and this one I will call it sxy. Okay, now so let's identify each one. Sx, okay, is summation of x, and sy summation of y, and ay is the average or mean, so it will be mean y. Okay, now we want to find we want to find s squared. Okay, s squared. So summation of we can write it by two ways. The first way, x dot times x, so it will be x squared. Also we can write it like x dot power 2. Okay, so it's also correct. So you can write it by this or write it by dot power 2. And xy is x dot x. Why we put x? Because it's a vector, array, or matrix, so we can't write x times x, we have to put dot here. Okay, now we finished all this one, so now we can create our matrix. We want to create this matrix. Okay, and we want to create this matrix, this vector or array as well. So now MA, I will call this matrix A, matrix A. So MA is n. Okay, first I identified n as length of x. Okay, then MA n SX, then this one to go for the second row. Okay, S semicolon SX SX squared. Okay, now MB I identified as SY, summation of y, and summation of xy. Okay, now then I can find A. So A will be the MA backslash MB. So it will be two array of two coefficients, A1, A0, and A1. Okay, now we finished. Now we can easily, this my MATLAB is finished, and I can show the A1 and A2, A0 and A1. Now I want to find also the R. So as you know, we have to find ST and SR. So in order to define them, we have to find the y regression. Okay, so now y regression equal A 2 between parentheses, because we want to extract 2 from A, the second row, times x, the value of x, plus A1, the first value, extract the first position. So now it will calculate y regression for each one. Okay, now we can then find ST equal sum y minus y mean, okay, or average, times y minus AY average, all between parentheses. So why I did this? Because as you know, if you remember, ST, where to write ST equal y minus y average overall squared. So in order to make this overall squared, I can y minus average y dot times y minus average y. Similarly, SR, so it's sum of y regression minus y dot times y regression minus y. Then I can find r squared equal st minus sr over st, and then you can find the square root of r squared. Okay, now we want to show the data. We want to show the result. So we can use the printf. Okay, now so we'll show the regression equation is y equal, we want to put some data here. So this is a format of data, and I want to, in order to make it clear, I will put it between parentheses, plus I also want to put some data here, okay, times x, okay, and slash backslash in single quote. Okay, then the data that data will put here will be a1, and the data will put here will be a2. Okay, so then again I want to print the coefficient. So this is to show the regression. Okay, if I want to show the coefficient of determination, so it's some data here, and it will be r2, and then the correlation of r is, and then I will put r2. So this is my function. If I apply this function, okay, then this trend line x and y. So we have two ways, either to trend line and then put x as here as a vector and then put y as a vector, or you can identify x and y before. Okay, first x and y, and then add trend line x and y. So it already, so this will be what is shown. Okay, regression equation is y equal and put the a1 and then a2 and then the coefficient 0.69 and then 0.98. Okay, 0.96 and 0.98. So we solved the we this is you can play it as you want and you can make it by different way. Okay, now we can do the same for the second order regression. So it's exactly what we did in the previous one. We'll repeat it again here. Okay, only the difference will be in the matrix, number of matrix, and the way we calculate them. So we have inputs, we have outputs, and we should make x should be equal y. Now, exactly the same way, function I called this function trend line 2 because it's second. So now this function is to create a trend line equation and to calculate its r and r square time. Now this is to check if x doesn't equal to y, then error. Okay, now we want to convert all to make all vectors in terms of vertical. So x equal x column and y equal y column. Okay, so we finish this part. Now we want to create the summation, each one we want to create each summation. Okay, so just we'll do summation of x, summation of y, ay average, and then we can find summation squared, summation cube, powered 4, xy, and x squared times y. Notice that here we make squared all dot. So we have two dots here. This one for the x to make it squared, and this one to multiply this part to y. Okay. Okay. Now we find we finish the definition of the items. Now we can create the matrices. So now n length. Okay, n equals the length of x. Okay, then we put sx squared then the second law is x squared is x cubed and so on, and define the MATLAB the MP matrix P. So similarly we've defined them. Then a will be ma over mb. So then we similar way we can find the y regression, but in this y regression we have more parameters. We have, you know, when we a here will be 3 items, 1 2 3. Okay, a naught, a1 and a2. So now y regression will be a3 times x dot over power 2 plus a2 times x plus a1. Okay, then we can find the st and sr similarly like previous example, and then we can find r2 and r1, and we can show use the same way to show the problem. Okay, now so I will put similarly the x and y, and then I will want to find them using trend 2. Okay, polynomial. So this is my new equation, and this is the correlation. Notice here the r is larger than the previous one, because since when you have higher order you have higher r. Okay, multiple regression. What does it mean by multiple regression? Multiple regression is used in analysis of relation between one dependent y and multiple independent like x1 x2 until xn. Okay, so for example you have one y, okay, and you have x1 and x2, and you want to find the correlation between them. So we have 3 coefficients. Also if you have more than I mean more than one x, so it will be a naught, a1, a2, a3. We have x1 x2 x3 and so on. And this one is very useful if you want to find correlation. Okay, for example, if suppose that you have like a tree, okay, and this tree has a length and it's affected by temperature and affected by humidity of the air, and so this is my y and this is x1 and x2, and you want to find the correlation between the height of tree and temperature, and so you can correlation. You have one y is the height of tree and you have temperature and humidity, for example, and you can find the correlation between them. So okay, now it's similar to the polynomial, okay, but it has a little bit different trend. So just to make it memorize it easy, okay, now we have uh, for the first row we put all the variables. So here we have the free or the 0, okay, and then the x1 and x2. If we have more, we put then x3 here, okay. Now here we assign each row for each factor. That means here's for for x1 and third row for x2. If we have more rows, so it will be assigned for x3, okay, and x4. Then multiply the first one to the second one. So n has x1 0, okay, so it will be only x1. Then x1, we set this line for x1. So now x1 times x1, it will be x1 squared. Okay, x1 times x2, x1 is x2. This one assigned for x2. Okay, then x2 times n, it will be x2. X2 times x1, x1, x2, x2 times x2, it will be x squared. Here we have y, and then put multiply for all x coefficient. So y, x1 y, x2 y, and so on. I think it's easy to predict the higher one. Okay, so you can predict it now. So now we put n x1, x2, x3, and then this is assigned for x1, this is assigned for x2, this is assigned for x3, and then we can multiply all. So it will be squared 1 2 1 3 and so on similarly. And here also we have y, okay, then x1y, x2y, x3y. If you want higher, I think you can predict the same as well. It's easy just to know how we create the matrices. Now if we want to create a MATLAB easily, similar way, okay. Now let's take this example. So in a corporation or company, the HR found that the employee's salary is a linear function of both age and experience. Can you help them to find the regression equation? Now we have this is their study. According to their study, they found people who has 5 years experience and their age is 18. Okay, this is their salary. And for those who are 7 and 20 years, they have this salary, and so on. Okay, so we have x1 and we have x2 and we have y. So we want to find the coefficient. You want to find the regression line for this multi-regression. How to do it? Now this is my example. We have experience, we have age, and this is the salary. And remember that this is my equation and this is my matrix. Okay, so first we will use Excel to solve this one, and then we will use MATLAB. So for Excel, now we want to find summation of x1, summation of x2, summation of x1 squared, and so on. So this will be my summations. Okay, summations. Now we can create like a matrix. So we have 5 in 5, and this is the summation. Okay, so we can create it x and x. This is x, or the coefficient. Okay, and this is b. Now remember that this is a and this is x and this is b. So if you remember, we can inverse this matrix to find a powered -1 and then multiplied by b, so we can get x like we did in part 1. So let's do this. Okay, we have our matrix. Okay, then we can we inverse the first matrix. Okay, if you remember, by when you this is some empty cell, we select them, and then in the function bar we put m inverse. Okay, and then select this one. Okay, from 0 from C10 to E12. Okay, so we select all, and then control shift enter, so this will appear. And after that we will move this part here. Okay, then I can make use m mult to multiply this one and this one. Okay, so in mult I want to multiply the inverse of A and B, so it will be two parts. First part of the matrix, and comma, we have the second part, the B, so we'll get, this is my result. So the equation will be 40,238 plus 6,794 times x1 minus 2,568 x2. So this is my regression equation. By this we how to use the Excel to find the regression. Okay, now let's go for MATLAB. MATLAB is sorry, MATLAB exactly what we did last time for the previous examples. The only way is to change the type of what the items of the matrix itself. So I called this function is trend multi. Here we have to put three imports. We have to put x1, x2, and xy. Okay, you can put any comments you want to add. Okay, then I identified n as a length of x1 to check the length. So if x2 doesn't equal to n, and or this for or, okay, or length y doesn't equal n, then error, end. Okay, when you start f you have to end it by n. Now we want to convert our vectors to vertical vectors. So x1 equal x1 column, x2 equal x2 column, and y equal y column. Now all all vectors become in vertical column, so we can find the summation of all. Okay, now we can do the parts of matrix. We can find summation of x1, we can find the summation of x2, we can find the summation of x1 squared. Now I didn't say x2 because the name will be more complicated because I have x2 here, so that's why I called here x1 squared. Okay, so it's summation of x1 dot power 2. So this will be x2 squared, so it will be summation of x2 squared, and so on. Then to create the matrix, we create the matrix here, and then the function a is ma backslash mb, and then you can do the finger f print f like before, and we can create our function like this. Okay, so now we put x and x2 and y, so then the regression line will be similarly like previous one, exactly what we get before. Okay, now we can also use a good function in Excel. It's called data analysis. Okay, data analysis. So when you go for data, you will find data analysis. If you didn't find it, you can go for file, and then for properties you can adds in, so you can add this data analysis in your data. Okay, now so once you select data analysis, this screen will be shown. So select regression, go for regression and select it, so this screen will be shown again. Okay, now put your x So we have put your y range, sorry, y range. We have a y, this is a dependent vector, and we have two independent vectors. So we input x, we select both of x. Okay, then okay. So when you do this, you will have this screen summary description. So we only interested here in the intercept a naught and x1 x2. Okay, so this is my coefficient. So now we learned different ways to find the coefficient using MATLAB, using multi options of Excel. Okay, I think this one is the best, or this one is the fastest way to find the coefficient. Okay, now we will go for one more thing. Now suppose that you have special equation. Okay, for example, you have that you want to find the function of independent, but with your own equation. Like for example, if you y equal, for example, you want to find cosine x plus cosine x times b, for example, times b plus sine x times c, whatever. So it is you can't find this one easily, okay, by using normal numerical. Okay, so we use something called least square curve fitting. Okay, so it's based on decreasing the SR. If you can decrease the SR to the minimum, okay, as you know, SR is y regression minus y true, okay, squared. Okay, this is summation. So if you can reduce this one, that means the value between your regression and your real value so is minimum. That means the coefficient is correct. So we will play with this, how to do it. Now suppose you have x and y, and suppose that this is your equation to build. Y equal a x over b times x. Okay, and now we don't know the a and b. So in order to do this, okay, we can start by initial guess values. Any values you can start by guessing them. Okay, so now we create y, x, y, and then we create our model based on the equation we want, this equation. Okay, so y equal this equation. So we create this model. Where's a and b? We just put a and b here, and it was fixed. We should make sure they are fixed. Okay, so a is fixed and b is fixed. Okay, and then when you drag to the right, all the model will be calculated based on a and b. Okay, now we have now the real y, and we have y regression. Okay, so we can find SR. Okay, how to find SR? We first should create here y minus yr, or yr minus y squared. Okay, for all of them, and then find the summation. Okay, so here's we have y true minus y regression squared, so we find each of them. Okay, then this is the SR, is the summation of all these values. So as you can see here, the difference between y true and y model the difference between y true and y model is large, so it doesn't represent the correct value. Why? Because the initial guess are wrong. Okay, now what we will do now, notice this. Now SR is based on this, the summation of all these ones. Okay, and this one depends on y model, and y model depends on a and b. Okay, so these are only the two independent. okay, and all others are dependent. So since you have one independent and one independent, you can solve by solver, you can find by solver. So now we'll use the solver. What we do, we open the solver, okay, from tab solver, and then set the objective. This is my objective. What should I do with this value? I should get it the minimum, okay. Don't try to get 0, because if you get a value of 0, you may couldn't reach this 0, and the model will crash. So make it minimum. So this is the most possible less value, okay. And then set the changing the variables of a and b, okay, and then solve. By this, the solver will do iteration to find the try to minimize the SR. So now this is the solution after solving. So now, as you can see here, SR becomes 0. We get perfect result, and this is 0 0 0 0 0. Now notice that Y model is exactly like Y model, exactly Y actual, and the trials I got 2.9 and 6.9, okay, 2.9 and 6.9. So this is my, since I know where is A and B, so this is my equation. I think it's easy. Thank you so much. We finished our tutorial today, so I hope you enjoy it, and see you in another section. Thank you so much. Assalamu alaikum warahmatullah.